Hello there. In this lesson, we're going to learn about static electricity and how it can be produced by contact. And so you can see that my daughter here has her hand in contact with this steel ball, which is a part of a Van de Graaff generator. And she definitely has a static charge, right? You can see all the hairs trying to get away from each other because they all have the same charge, probably negative, and they're trying to get away from each other. So getting a static charge can be produced in three different ways. You can get it by friction, which is rubbing two objects together. You can see we got a balloon here, and you got my hair, and if you rub these two together, you'll get friction producing static charge. You can get it by just contacting something that already has a charge. So they call that conduction, because the electrons can then flow from one object to the next. And you can get it without any contact through induction. So you might have an induction charger for your phone. You might have seen that term being used there as well. So the first two is what we're going to do in this lesson, which are the ones that involve contact, things touching each other. So friction is the first method of charging that we're going to look at, and you've probably seen this process before. I always noticed it when my kids, if they're wearing like some sort of synthetic fabric like polyester or fleece, if they wear that as they're sliding down the plastic slides at the park, that their hair will end up standing up by the time they get to the bottom. And so you've also might have seen if you're wearing wool socks and you rub them against a carpet, that you can get a static charge built up that way as well. The key thing here is that the substances have to be different from each other. You can't have wool socks on a wool carpet or plastic clothes on a plastic slide, the same type of plastic anyways. They have to be different enough so that electrons can be transferred from one place to another. And so if electrons, say, get transferred from the carpet into the sock, that means the carpet's going to be left with a positive charge because it loses electrons, and the sock's going to end up with a negative charge because it gains them. So there's a transfer due to the friction that occurs. It turns out that different substances have a different attraction or kind of grip on the electrons that they possess. And so if you rub two different substances together, you can predict which way the electrons will flow depending on how their relative attraction to electrons is. And so the fancy term for this is a triboelectric series, or tribo, I'm not sure how you pronounce that, or electrostatic series, another term for it. And that's just arranging substances in order of their grip on the electrons. And so substances that have a strong hold on their electrons and tend to pull electrons away from other things will be at the bottom of the list, and the ones that tend to release their electrons and lose them will tend to be at the top of the list. And so if we have, say, a wool sock and a nylon carpet, well, let's look for wool. There's wool and there's nylon. So the wool is a little lower down, so it'll tend to gain electrons, so it'll probably end up with negative, whereas the nylon, even though it's just a little bit higher up, will end up with positive because the electrons will be transferred that way. Here's a couple others that you probably get a chance to try out in class. This is a glass rod here, and this red fabric here is silk. So this is a pretty common one to try. If you're going to do it in class, make sure you wash that glass, make it nice and squeaky clean so there's no fingerprints and other gunk on it. And then when you rub the one against the other, if you look on the series, you'll see silk is here, and you see glass is up here. And that means the glass is going to give up its electrons to the silk. The silk will end up with a negative charge, and that glass rod will be nice and positive. So the electrons will go from the glass to the silk, and you'll end up with a positively charged rod. So that's good to know. So using this electrostatic series, you can always give something a positive charge if you know the two substances that you are rubbing together. Another classic one is ebonite. So ebonite is a extract or sap of a ebonite tree, and you can form it into rods or whatever shape you want. But the classic thing is to have a rod made of ebonite and take some animal fur of some sort, like rabbit. And if you rub those two together, the rabbit fur is higher up than the ebonite. It's about as far away as you can get on this series. And that means that the ebonite for sure is going to have a very strong negative charge because it's going to take electrons from the rabbit fur. So go from the rabbit fur to the ebonite rod, and you end up with negatively charged rod. So you can get a nice positively charged rod with the glass and a negatively charged rod with the ebonite, and we can do a couple comparisons with those things later on. All right, so the second way of getting a static charge is by contact, and it depends on the object what type of charge you will get when contact is made. So if we take something like our negatively charged rod and we touch it to something that's neutral, like this electroscope, you'll see that the electroscope becomes charged, right? You see these leaves have moved apart away from each other, and that's because the extra electrons in the rod, a few of them anyways, will go into this electroscope and spread out down into these leaves, and that causes the repulsion. So in this case, the electrons are being added into the object, and the object ends up being negatively charged as well. The rod will have lost a few electrons, but it'll still stay negative as well. If we do the other substance, if we take the glass rod that was positively charged and we touch it to the electroscope, you see we still get some movement here. Those leaves aren't perfectly straight up and down. They've moved apart a little bit. And that's because they also have a charge. This time, the rod will attract electrons out of the electroscope, and that means what's left behind here will be slightly positive, and you will have transferred a positive charge to the electroscope by contact due to electrons leaving. All right, so a Van der Graaf generator kind of does a little of both. It will have different substances, usually rubber or nylon or acetate, for rollers that roll and have friction against a belt that is usually made of some other substance like rubber. So let's say that this is rubber and this is like acetate. When the rubber rolls over the acetate, it's going to pick up a charge. So let's say it picks up a negative charge. It's going to carry it all the way up here, and then it'll get transferred to this ball on the outside, and the whole outside of the ball will end up being negative. And then if you are standing with your hand on that ball, well, those electrons can find their way into you and give your whole body a negative charge as well. It only really works well if you're standing up on something. So let's say we're putting this up on like a wooden block, so you're not in contact with the ground. And then if everything in you gets a nice negative charge, that means that the hairs, which are a little mobile, will move apart from each other, just like the electroscope, and you'll end up with spiky hairdo because of the repulsion.